My name is Lorenz Killer, and this is my introduction to reinforcement learning. What we learned so far with supervised learning is that if we have some kind of training data, for example this picture of cats and dogs, we can apply an algorithm to get the model and apply this model to new data to also find out the class. Disadvantages with this approach though is first of all that we need a lot of data and we need to get this data somehow. So any kind of additional work is needed. It could be human work or for example an algorithm. Another disadvantage is if you take a look at this picture, even for humans it can be hard to tell if it's a cat or maybe a dog. This means our training data can sometimes have errors, and since we're constantly trying to replicate the training data's behavior instead of actual thinking on our own, this means that we just cannot get better than our training data allows us to. An example is chess. In chess you have a lot of these possible games, which means it's impossible for us to have the full data set of all possible moves. That means we have to take a subset, but where do we take this subset from? Well, there are several options. For example, we could take a look at one of the best chess players or take the data from another chess program, but we could never be better than this chess world player or this program because instead we're always trying to replicate its behavior. This is where reinforcement learning comes in. The basic concept is as follows. We have some kind of agent and some kind of environment and they interact with each other. First of all, the agent gets a perception of the environment. He processes this perception and calculates a state out of it, and based on that state the agent will take an action. This action in return changes the environment again, and so the loop continues. To find out if the agent actually does a good job, he also processes a reward from the perception, and with help of this reward he can learn. But how does he actually learn? Well, we could say that x at t, based on any point of time, is just the state we're currently in. A is the action that we're taking at this point in time, and the policy is based on the current state we're in and decides which action we should take. Well, then we can also say that R is the reward, which is always based on the current state and the last action to find out if we actually did a good job or not. Then we also need a discount factor, we call it gamma. This is just there to make older experiences less valuable than newer ones. And with this we can define the value function. The value function is basically based on our policy a sum over all the rewards we will get at each point of time. And our goal is to find the optimal policy pi star that maximizes this value function at all time. How can we actually do this? Well, there are tons of algorithms. You can divide them between model-based and model-free approaches, but I will not go into further detail of any of them. Instead, let's take a look at two more problems which always follow us in reinforcement learning. Number one is exploitation versus exploration. Exploitation is basically if the agent always chooses the action which leads to the highest known immediate reward, and exploration is if the agent instead maybe explores the environment in order to learn new things he didn't know before. We need to have a good balance of both, and there are a few methods to do this. For example, epsilon greedy approach, where the agent tries to explore all states before and exploit later, or a fixed or decreasing exploration rate all the time. Another problem which also always follows us is reward shaping. That is because of a lot of problems in reinforcement learning. They have a sparse reward setting, for example chess, where the only reward is actually just winning the game. And this means for two complex problems, maybe our agent will never be able to learn because he doesn't reach this goal at first with random actions. And a solution for that is probably for example, to introduce sub-goals. So we have multiple steps and the agent can learn earlier. Problems with that are though that it's highly dependent on the problem. So we need to do this for every kind of problem. Think about what sub-goals there could be. Also, there's the danger of limiting the freedom of the agent. For example, in chess, if we tell the agent that it's valuable to kick other pieces, maybe he will not be able to learn other strategies. And it's also not always too easy or intuitive to find these sub-goals.